Hey there, Trig students. Good to see you guys today. This is week four of distance learning. So have your tests. I'll be working on grading those on Monday, maybe possibly over this past weekend, whenever you're watching this video. But yeah, so far things look good. I appreciate your work and making sure that from what I've seen I've looked at about half dozen tests so far. This is Thursday, April 16th right now, but I've been happy with just seeing the a level of organization you guys have been putting in and stuff. So minimal complications along the way. Some people had a couple struggles or whatnot, but overall good job. Thank you for your work. Again, I just want to really encourage you guys, if you need any help at all during the course of the week, please don't hesitate to reach out to me. A lot of kids, we've been able to meet back and forth via the camera and figure some things out. I think that you're going to find that a lot of the content that we learn from here on out is going to be pretty straightforward. I think you actually got through the most difficult stuff. And so if you really follow the course, I think, just participate and do the problems you're supposed to. I think you're going to find this very, very doable the rest of the way. And for your next section, so we kind of finished up our complex numbers, and now we're going to step into vectors. And after vectors, we're going to step into what we call conic sections. So those are really the three main things for your trigonometry course that we need to make sure are ready to go. So let's look at vectors right now. What is a vector? Well, this is a coordinate. X, Y is a coordinate. Vector has brackets like these, okay? And so kind of give you a couple different examples of a vector. If you would plot the coordinate 3, 4, here you go over 3 and up 4. And so that would be the coordinate 3, 4. But vector 3, 4, that's slightly different. Vector 3, 4 looks like this. So you can see how it's very related to our imaginary and complex number analysis that we just went through, because that's kind of how we graphed the a plus b I values. So what's interesting about a vector is that it has direction. So it's headed in a certain direction, theta, and it also has magnitude, meaning it stretches a certain length. And we really like to use vectors to represent things like force. It's something that's very useful when we get into studies of physics. And so, and you're going to see some of those examples come up. Let's do an example of doing some addition, subtraction, multiplication with vectors. You see vector 3, 4 plus vector 1, 3. Now, if I take vector 3, 4, 1, 2, 3, 1, 2, 3, 4, that's right here. And I'm going to add on to that vector 1, 3. So from this spot, I would go over 1, and I would go up 3, 1, 2, 3, over 1 and up 3, and I get to that spot. So two vectors can work on each other, and the result is actually this. That's the resulting vector, is from there to there. How do we compute that? It's very simple. 3 plus 1 is 4, and as you can see, your new spot is over 4 units, and then 3 plus 4 is 7. And you can see that it is, in fact, up 7 units. You use kind of this, this triangle thing off to the side, 4, 7. That's what it looks like as a vector. So that's how we write that notation. Your Google Doc equation editor does not have one of those options. So you'd have to find another equation editor or just write it out. If you'd like to use an inequality symbol, like this, 4, 7, the inequality symbols are kind of, a little bit too sharp, but I can understand that notation. That would be just fine. So you choose what you want to do. I tried to write mine up pretty neat as I was making the examples. So vector addition, pretty straightforward. Let's look at some operations with vectors that don't fall directly under that category, but are very much related. If we say that vector b is equal to -1, 3, and vector w is equal to 6, -2, we would like to compute the following. We'd like to do 2v, and then we would like to do -v plus 3w. Okay, so if we want to perform operations with vectors, they act just like you think that they would. So 2 times vector v would be 2 times -1, which is -2, and then 2 times 3 is 6. So it works really nicely, just exactly like you would hope it would. And so if we do this one, we take -v, which is going to be 1, -3, and we add to that 3 times w, which would be 18, negative 6. As you add those together, 1 and 18 makes 19, and negative 3 and negative 6 make negative 9. And so there you have, right in front of you, the new vector. So you're going to have to perform vector addition, and that's going to, subtraction, multiplication. That's going to really get you through your first problem set on your assignment. To get through your second problem set of the assignment, we have to look at another piece here, and that is this. Okay, maybe you recall the movie, what is that? The criminals running around, Disney Pixar movie. Despicable Me, yeah. Okay, so there's a great movie. Love it, one of my favorites. And one of the evil guy's name is Vector, and because he has both magnitude and direction. And so magnitude and direction are things that are. There's a line in there about you got to go back and watch, but it's kind of funny if you understand math and science. But magnitude and direction are really two key and important parts that have to do with a vector. And they're not very difficult to find. You're going to find exactly why we relate them to you in the course of trigonometry. This is the magnitude of the vector. We say that the magnitude of a vector is the absolute value of the vector, or the distance it is from 0. How do we compute that? Well, you go over A units and up B units. So if I go over A and up B, that brings me to that location. How do I find the magnitude of the vector? Turns out that the magnitude of the vector, you're thinking it right now, is the square root of A squared plus B squared. I hope that that looks familiar to you because we just did that in the last unit. So this unit builds very nicely off of the last one. It just uses new notation, that being vectors. The direction of the vector, we would say, is the angle. And we like to work in degrees when we are working with vectors because they have application to science. And science likes to work in degrees, not radians. Mathematicians like to work in radians. We're kind of different. So that's magnitude. How do we do direction? You guessed it. We solved tangent of theta is equal to the b value divided by the a value. So if you're taking notes, that's a really, really important one that you want to make sure that you write down. So this is kind of probably one of the most important things to have down as you prepare for your next assignment. So in problem set 2, you're going to find both the magnitude and the direction of certain vectors. So we're going to look at 3 vectors here. We're going to look at the vector root of 3, negative 1, and negative 5, 5, and 6, negative 2. Okay? And for each one, we're going to find the magnitude and we're going to find the direction. So the magnitude of this vector is equal to the square root of, I square that and I get 3, and I square that and I get 1. So the magnitude of the vector is equal to 2. Okay? How do I find the angle? Well, subtangent of theta is equal to my b value divided by my a value, or negative 1 over the root of 3, which is negative root of 3 over 3. Now, we produced a document in our previous notes that talked about where is tangent equal to the root of 3 over 3. That would be a 30-degree angle, but we have to set up our quadrants in order to figure out where I am. So I go over the root of 3 and I go down 1. So that means I'm in the 4th quadrant. And a 30-degree angle in the 4th quadrant is going to give you theta is equal to 330 degrees. So your answer would be the magnitude of the vector is 2 and theta is equal to 330 degrees. That is your answer for this first one. Okay? So very similarly building off of yesterday, just making sure we're talking about vectors. Negative 5, 5. Square root, so the magnitude of the vector is the square root of 25 plus 25 So that's the square root of 50. If I take out a 25, I get 5 roots of 2. Okay, so that should be old hat, easy business for everybody here. Then we go ahead and we set up tangent of theta is equal to b divided by a. So the tangent of your theta value is going to be equal to b divided by a, or -1. Again, using that chart that I gave you, where's tangent equal to 1? That's going to be a 45-degree angle. But 45 degrees is not my answer. I set up a 45-degree angle in which quadrant? If you were to plot this, you would get to the second quadrant. And a 45-degree angle in the second quadrant is going to give you theta is equal to 135 degrees. So therefore, as you glance at that, we have the magnitude of the vector is equal to 5 roots of 2, and theta is equal to 135 degrees. And so that is your answer for question number 2. Really frustrated with my marker right now, so I'm going to get a new one quick. And my last one here, magnitude is equal to square root of 6 squared is 36, and -2 squared is 4. 36 plus 4 is 40. The square root of 40, I take out the perfect square, which is 4, and my result is 2 roots of 10. I set up tangent of theta is equal to b divided by a, and that would be a -1/3. -1/3 is not a special tangent value anywhere, not a special tangent value at all. So we can't simply just think about our unit circle and find those properties. We actually have to use our calculator. So I go ahead and I take out my calculator. I make sure that I'm working in degrees, and once I'm working in degrees, I do second tangent or tangent inverse of 1/3, 0.3 repeating, and I get 18.43 degrees. So that means that theta, the reference angle, is at 1843, but I need to be able to figure out which quadrant I'm in. Over 6 and down 2, that means I'm in the 4th quadrant here. And so I have an 18.43 degree reference angle. So I'm going to subtract that from 360. 360 minus 18.43. And you guys all know I get 341.57. So theta is equal to 341.57 degrees. Or, if I write the whole answer, the magnitude vector is 2 roots of 10, and theta is equal to 341.57 degrees. Sorry if I kind of ran out of room over there, but you kind of get the idea. And there we have it. So, in this lesson, you've learned to be able to add and subtract, multiply properties of vectors, and you've also been able to learn how to find the magnitude and the direction of the vector. That will take you through problem set 1 and problem set 2. Produce another video which will produce for problem set 3. Not going to be quite as long. Hope this was informative. If you need help, please reach out. I get lonely. Have a good one. Take care.